Good afternoon. Today we are going to see some questions which can frame in MCQs. I am not going to give four options and then solve it. So we are with questions. A bar of length 1 meter is heated through 50 degrees centigrade. Area of bar is 100 square and the coefficient of thermal expansion is 15 into 10 raised to minus 6. So this is per degree centigrade. If the bar is kept free, then increase in length of the bar is. Now we have delta L equal to L alpha T for change in temperature. Now L is given 1 meter, then alpha 15 into 10 raised to minus 6, and then we have T which is equal to 50. And then if we will solve this, then we will get this value as 0.75 millimeter. You may have four options. First option is given 0.5 millimeter. Second option is given 0.75 centimeter. Third option may given 0.075 centimeter. So fourth option is given none. So you have to keep in mind 0.75 millimeter means it goes to 0.075 centimeter because we have to divide it by 10 and that answer will go to this. So conversion of units you should be in position. Then a bar of length 1 meter is heated through 50 degrees centigrade. Same question we have. Now the bar is kept free. Then the stress in the bar is, now here we have 0. So no stress. So that is most important. When bar is kept free, then it is also free from stresses. So that we have to keep in mind, that free keeps bar free from stresses, and that we have to keep in mind. So then we have next, a bar of length 1 meter is heated through 50 degrees centigrade. Area of bar is 100 square. And then we have to find stress in the bar. Now here you have to keep in mind bar is kept between rigid support. Now actually we know we have delta L equal to L alpha T. If you rearrange the terms, delta L upon L, that is equal to alpha T. This is strain, and strain we can write at stress upon E, which is alpha T, and therefore my formula becomes alpha TE. Now alpha we have 15 into 10 raised to minus 6. T we have 50 and E we have 200 into 10 raised to 3. And then we have 10 raised to 3, 4, 5, 10 raised to 6. This gets cancelled. And then we have 5 2s are 10 into 15. So we will get it as 150 ampere. So stress in the bar is 150. So if it is your expansion is prevented, then only stress will be developed. If expansion is allowed, stress will not be developed. If the length of the bar is doubled, then the temperature stress is. Now here we have length of bar is 1 meter. So in last problem 1 meter, here we will take 2 meter. Is there any change? No, because so then the temperature stress remains same. Now you may have different option, remains same, is doubled, is half. So likewise you have options for this. And then keep in mind stress is alpha TE. It is independent of length. So whatever change in length, so that will not affect your stress. Now in this, you may have question that thermal coefficient reduced by 50%, then stress will be reduced by 50%. So now this sigma proportional to epsilon, sigma proportional to T, and sigma proportional to E. So whatever reduction or increase in alpha, same reduction or increase in stress. Whatever reduction or change in temperature, same will be in stress. and whatever changes in E means if you made E half, stress will be up. If you made E doubled, stress will be doubled. So whatever change you will have here, so same change you will get over here because it is directly proportional to these quantities. If two bars are in parallel, now keep in mind this is most important one, and connected rigidly, temperature of the bar. Now this is again important. Decrease by 50 degrees centigrade. If bar 1 has thermal expansion more than bar 2, then the stress in bar 1. Now try to understand this. So we have this as bar 1, and then we have another which is bar 2. Now thermal expansion of bar 1 is greater and bar 2 is less. Now what will happen? Now temperature is decreased. So this bar will try to shorten more. Means if you will keep free, then you can have this bar is in this way. That is first bar, and second bar we are going to be in this fashion. Now to keep both along the same length, we have to increase it and we have to decrease it. So we will have tension in this bar, that is first bar tension, and second bar we have compression. So tension, first bar, first bar, and compression, second bar. Exactly, now we have second bar. So that we have to keep in mind. It is increased or it is decreased. So here it is decreased. So bar having higher, greater thermal expansion, and that will be shortened more than the second, and therefore that we have to keep both along same deformation. We have to apply tensile force to this. Now you can have this question, what is change? So temperature is increased, and if temperature is increased, what will happen? Then my bar 1 will be deform more than your bar 2, and in this case what will happen? We have to apply compression to this, we have to apply tension to this, exactly reverse. So here bar 1 compression, and here bar 2 tension. But if it is decreased, then you can see we have exactly reverse. Bar 1 will go in tension, bar 2 will go in compression, because these are, again, this is most important, you have to see it is in parallel and increased, and then one has greater thermal expansion than 2. Then we have two bars are in series. Now keep in mind this is series and temperature is increased by 50 degrees centigrade. If one has greater thermal expansion than bar 2, then stress in the bar is. Now when bars are in series, both bars have same nature of the stresses. Both bars have same nature of stresses. So that is most important. So whatever one, so we have same. Whereas if we will go in parallel, so we have exactly opposite. One tension, second compression. One compression, second tension. Here we have both same, and therefore his temperature is increased. Bar will try to elongate. So we have in series, means we have like this. If we have this as one bar, then we have this as second bar. So now here we have bars will try to deform, and we have to keep it in same length. So we have to apply compressive reaction. So in both bar 1 and 2, we have compressive stress. Then the stress in bar 1 is compressive. So that is most important. Here we are not going to calculate the values. Now if decreased, so if you are going to decrease, then what will happen? So bar will try to reduce, or its deformation is again decreasing, it will try to shorten the bar. We have to keep in same position, so we should have tensile reaction, and therefore stress in bar 1 is tensile. So that you have to keep in mind. So which type of stresses are developed in series? we have both bars have same type of stresses, whereas in parallel we have exactly opposite. Now a steel rod L diameter D fixed at both ends is uniformly heated through rise temperature T. The Young's modulus is E, and alpha we have thermal coefficient. Then thermal stress sigma is alpha TE. It is independent of your length and independent of your area. It depends on thermal coefficient, temperature change, and modulus of elasticity. So length and area will not cause any change in your thermal stresses. So you may have question that thermal stress depends upon, you may have length, you may have diameter, you may have alpha, or none of this. So here you can see four MCQs you can have. So one we have sigma, then depends on area, depends on length, depends on diameter, depends on alpha. This is answer is we have alpha. You may have second question. Sigma A depends on L. So depends on D. Depends on T. So we have answer is T. So likewise MCQs you can have number of MCQs. I will not go for this one. We have to actually go for concepts, and if once we have these concepts then we can have answers for the MCQs. So basic you go. So we have like this, and then we can have this three answers. So we can have these three MCQs from this. Then we have a steel bar 10 millimeter diameter is heated through 10 degrees centigrade to 50 degrees centigrade, and the bar is free to expand. So again you have to keep in mind. Then bar will induce. Now student have sigma is equal to alpha T. They are going to calculate and write the answer. No, keep in mind bar is free to expand. So the bar will induce zero stress, no stress. So that we have to keep in mind. That is most important. Otherwise values are given, we try to put it first and then we will put the answers. So we should not go likewise. So then we have the length, Young's modulus, and coefficient of thermal expansion of bar 1 are thrice that of bar 2. If temperature of both is increased by T, then the ratio of stress developed 1 and 2. So now we have sigma 1, alpha 1, T1 even. Then the ratio we have to go for sigma 2, alpha 2, T2 and E2. Now you can have the length, Young's modulus, and coefficient of expansion thrice. So we have 3 alpha 2. Alpha 1 is 3 alpha 2. Then we have Young's modulus. So E1 is 3E2. And then L1, that is 3L2. So we need not require to go for L1. So 3 alpha 2, temperature is same. T1 is equal to T2. Then 3 alpha 2 into T into 3E2 and divided by alpha 2 T into E2. And from this we will get 9. So ratio we have, that is 9. So any value may be given, that is alpha 2, that is alpha 1 is equal to alpha 2, E1 is equal to 2E2. So you have to keep in mind, and you can have number of MCQs you can frame on this. So do not run behind MCQs. Try to understand the formulas and put the values. If only alpha 1 is given equal to 2 alpha 2, then your value sigma 1 upon sigma 2, that will be twice only. So that you have to keep in mind, because if you will go through the books, then keeping different values, you can get number of MCQs for it. So these are the questions which are related with your temperature stresses from unit number 1. So remaining part we will see in next video. Thank you.